Question 6 is all about a small steel ball being fired by a catapult. The diagram here shows a top-down view of the elastic cord on the catapult being stretched and the ball is loaded ready to fire. There's an angle between the two 30 Newton forces of 45 degrees. Now there are different strategies available to solve this problem. We could use a scale diagram. Alternatively, we could add the two 30 Newton vectors head to tail, not in a scale diagram, but instead use the cosine rule. What I'm going to show you here is how to solve this problem by breaking the two vectors down into their components. And what I mean by that, you can see that here in the red, I'm breaking up my diagram into a red force triangle where I can identify X and Y components, and I can do the same in black now with the lower 30 Newton vector, so I can identify X and Y components in that triangle as well. And I can add together the two horizontal contributions there to obtain the total horizontal force. Let's look at the top triangle first. So I have my force vector, its magnitude is 30 newtons. And I can show X and Y components of this vector, and we'll call these components Fy and Fx. Now, in the original diagram, I had an angle of 45 degrees in between my two force vectors. What I've shown here is half that angle because my Fx line is bisecting the angle. So my angle would actually be 22.5 degrees. Now we know from our earlier work on vectors that Fx is given by 30 cos theta. And that's 30 multiplied by the cosine of 22.5 degrees. And that comes to 27.7 newtons. So that's the horizontal component of the upper 30 Newton force, giving me 27.7 newtons. Now this is a special case. You can see that the lines that I've drawn to split my shape up into two rectangles actually bisects the diagram, so we have symmetry here. Now we might not always have symmetry, so I'm just going to show the bottom vector being calculated out into components just for completeness. So again, we have a 30 Newton vector. I'm putting in the Fx and Fy components here. Now the calculation is going to be exactly the same as before. Fx is going to be 30 times the cosine of theta, and again that will be 30 times the cosine of 22.5 degrees. So once again we have a horizontal component of 27.7 newtons. So due to the symmetry of this situation, the total horizontal force would be twice either of my Fx components. In other words, it would be 2 times 27.7 newtons. So my total horizontal force in this problem is 54.4 newtons.